The purpose of this screencast is to discuss recrystallization and grain growth. Whenever we work or process a material, we can anticipate that we're going to plastically deform it, and when we do this, we end up storing energy within the material. So this energy is going to be stored in the form of additional dislocations or increased grain boundary surface area. To give you an example, if we roll a material, so this means that we go ahead and we take a piece of material and we're trying to go ahead and flatten it so the thickness of it is reduced. As you start to roll this material, the one side you will have your original size grains, which will end up entering the roller. These grains are going to end up elongating as they go through the rolling process. In the grains that have elongated, we can expect that we have additional dislocations and increased grain boundary surface area. So in essence, we can anticipate that these grains are going to end up having more energy on this side after processing. Recrystallization is a process that allows us to actually restore our grains to the original, like we see back here, to this original state, and it ends up being a lower energy state for the grains. To explain the lower energy state, we can use a balloon as an analogy. If you sit on a balloon and make it flat, the balloon is going to have an increased surface area. However, a balloon wants to actually go to a lower energy state, so a decreased surface area. So if you were actually sitting on it and you got off the balloon, it would automatically pop back to its original shape. Grains work very much the same way in a metal. Once you've deformed them, they've become elongated. Like the flat balloon, they want to pop back to their original round shape. And then this is what recrystallization is all about. Our original drawing of showing a piece of material that was being rolled is representative of what happens with materials during a process called cold working. So right after cold working, our grains have typically become elongated. So this picture represents right after cold working, you have elongated grains. You can anticipate during this time a few different things. Number one, you can expect that your material strength has gone up. So right after cold working, you have an increase in strength, but you can also anticipate that you have a decrease in your ductility. If you were to go ahead and add heat at this point, what you would find is you start to have atomic diffusion that's enhanced. And because of this, you end up reducing the number of dislocations as well as dislocation configurations. The result of this equals a reduction in internal energy. As a result, what we start to see is a nucleation of new grains. So this nucleation of new grains that's occurring is what we call recrystallization. During recrystallization, we can anticipate that we're going to see our strength start to lower on us, but we'll also see an increase in our ductility. Something important to note is with recrystallization is that the more you work a material, so the more you cold work a material, the more internal energy it's going to store. As a result, with more internal energy, it takes less heat to go ahead and start recrystallization. Recrystallization is actually how we define hot working versus cold working. So cold working is defined as processes that are below recrystallization temperatures. And hot working is considered any processes that are occurring above recrystallization temperatures. So recrystallization is going to actually be dependent on both the material as well as the percentage of working it has received before you start to heat it up for recrystallization. So one final note is, after a material has started to recrystallize, what happens if you continue to heat it? So if you do continue to heat, what you're going to end up finding out is, we're going to go back up to our diagram at the top here. So if you go ahead, you continue to heat your material, you'll find that these grains will actually start to grow larger and larger on you. So sometimes you'll hear recrystallization termed recrystallization and grain growth. So this grain growth that has occurred right at this region has different properties than our smaller, finer materials that we had right as recrystallization started. So recrystallization, once it starts, has these nice fine grains at the beginning, and then through grain growth, we start to get these larger grains. And the difference between these two grains ends up being properties. Typically with grain growth, what we're going to see is a decrease in our engineering properties. So overall, one can see how we can use recrystallization to our advantage. So in the case of hot working, where we keep it above recrystallization temperatures, if we're doing something like rolling steel, every time you roll it, at the end of the rolling process, it's going to recrystallize. So every time you reduce your thickness, it'll keep recrystallizing, keeping the engineering properties where we want them, and allowing us to process that material all the way through to go from an initial thickness all the way down to our final thickness that we would want for that steel.